Do y'all have audio back now? You might have lost it when I was saving that file. That probably kind of maxed out my CPU for a second. All right, so chapter 16 is the last chapter that we will do tonight. It's in two parts. It's on networking, and I'll go through a lot of this pretty quickly. Most of you have had the Net Plus class at this point, so a lot of this is going to be repeat for you. But feel free, if I'm going too fast or I don't go over something, throw a question in that chat window and I'll back up and go over it. And then don't forget, you need to watch 17 and 18 before we have class on Thursday. So we're going to talk about the network models. We're going to talk about internet connectivity. We're going to talk about protocols, IP applications, and network topologies, and finally network types. So in the networking world, there are two major network models, the client-server model and the peer-to-peer model. And in the client-server model, the servers provide services to the clients. A print server handles printing, a web server handles HTML files. A domain controller handles giving username and password access out to users. These are centralized security and auditing and network management. Peer-to-peer is what you most likely have at home. Each workstation is independently managed. All security is managed locally on that computer. They have limited growth due to the lack of manageability. Files are shared with each other but must be individually shared on each machine, which is time consuming. Peer-to-peer is actually what I have set up in our lab at Barksdale because I don't have that many computers and we're not sharing anything. So it was easier. I didn't worry about, needing a central server for us to connect to all the time. We do have a web server there, so we do have some client server stuff, and we do have a print server, but the general computers are each in control of everything on their own machines. So there are different types of internet connectivity. Dial-up, broadband, DSL, satellite, and then what you call trunk lines or T1 lines. And we'll kind of talk about each of these. Dial-up is an old technology, but believe it or not, there's still a lot of places that use dial-up. And the reason is that the telephone network is extremely stable. Telephone modems, the word modem comes from modulate, demodulate, which is what the device does. It takes a digital signal from the computer and modulates it so it can be sent out analog over the telephone system. And then on the other end, it demodulates it so it can be back into digital onto the system so that the data can be transferred between two over the telephone system. The maximum speed of a modem is 56K, and that's if you've got a crystal clear phone line. That's really not attained very often. They can be internal or external. If it's an internal one, follow the precautions when installing it. IDSN, or Integrated Services Digital Network, uses a modem and a phone line, but it transmits at 128K, and these are often used as backup lines for faster connections. Broadband service is your cable modem, and I get into this with the Net Plus folks. I won't really go into it so much here, but they really shouldn't call a cable modem a modem because it doesn't modulate or demodulate anything anymore. Nowadays, almost all cable systems across America are digital cable systems, so the modem is simply changing, changing the way data is transmitted, but it's not really changing it from digital to analog. Now, having said that, everybody calls them a cable modem, and that's not going to change, but it's technically not a modem. DSL is another option for connectivity at home. With DSL, you have dedicated bandwidth, but it's dependent on the distance from the phone company as to what kind of quality of service you're going to get. And satellite, their slide here is outdated. Their slide says satellite requires a telephone for transmitting service requests. Old satellites did, but the new satellite services actually will transmit and receive on the satellite. But they use a dish with a very precisely focused antenna. Here they're showing a DSL modem. You would have a connection in, which is an RJ11 connection. That's your standard connection on a phone line. And then RJ45, remember, is the larger network connection. That would go to the computer. One thing about DSL is that all of the phones in your house that aren't on the DSL modem have to have a filter on them. So here they show the filter as a little external device. I've seen jacks that have the filter built into them, but you've got to filter everything except the line that goes to the DSL modem for your phone lines to function properly. If you don't, you're going to hear static in it when the modem's in use. Here they're showing a cable modem going to a single PC. They've got a splitter run into the cable modem and then the TV. And then on the back of the cable modem, they've got coax running in and then a USB or an RJ45 port run to the computer. Most of you at home probably have this set up, except instead of running to your computer, you got an RJ45 wire running to your wireless router, and from there it's going to your computer. So LANs allow more than one device to access the internet with a single connection. They require some sort of internet access and then a router. And a router's sole purpose is to forward data packets from the internet or from another network to a local network. And you can make a computer act like a router by turning on what's called internet connection sharing. So here we're seeing our connection to the internet. We got a router, and then a router's going to have a default gateway. Then we've got a switch and computers that are connected to that switch. So to get to the internet here, this computer would talk to the switch would talk to the router would then go out to the ISP. So there are lots of protocols. And a protocol, all you really need to know about a protocol for this test is think of it as a language. In order for a computer to communicate, they have to have a common protocol. If I speak only French, for example, and all of you in the class only speak Spanish, we don't have a common language. We can't communicate. But if I speak French and English and you speak Spanish and English, then we can communicate because we have English in common. Protocols are just that. There's something that's got to be in common for computers to communicate. And the world is dominated by TCP/IP now. There are others, but there's really no need for you to know them at this level, at the A+ level. So TCP/IP, some things you should know. The term ISP means Internet Service Provider. HTTP or HTTPS, Hypertext Transfer Protocol, and then HTTPS is Secure Sockets Layer over Hypertext Transfer Protocol. And then TLS is the successor to SSL, and it stands for Transport Layer Security. HTML is the code that pages are actually written in the web on, and it uses these things called tags to separate data types. FTP is a file transfer protocol, and it is used to transfer files, but it's unsecure. Telnet's another one, and it's also an unsecure method of remote access. Secure Shell SSH is the encrypted version of Telnet, so it's the remote access that's encrypted. And then finally, DNS, or a domain name server. That is what allows you to get on the internet and not have to put in an IP address every time you want to go to a site. DNS is what takes when you put in google.com and translates that to the IP address to actually go out on the internet. And they compare it to like a phone book of the internet. SMTP is a simple mail transport protocol. and that is used by servers to send email back and forth. SNMP is Simple Network Management Protocol, and that is used to manage devices on a large network. A lot of your big switches and UPSs and things use SNMP, and you can hook them onto your network and give them an IP address, and they'll report back to a central place on things like the temperature in the room they're in, or if they're running properly, or if they need a reboot, or things like that. So ports are also important, and every IP address has different ports that can be assigned to different applications. And there are some that are common ports, like port 80 is in general the port used for web servers. But just knowing that ports exist are important. You won't need to know any of the ports really for this test, but there are 65,535 of them possible, and that's what allows a server to run more than one thing. Without ports, then a server that was a web server couldn't be an email server as well. It would have to just be a web server. Alright, so other terms to know are the different types of topologies on a network. A bus uses a common cable, like a piece of coax. A star is what most places use, and that's a central switch or an access point that connects all the computers together. A ring is not as common anymore, but they're being used in larger backbone networks. And a ring meant the computers were connected like token ring to the computers closest to it. Each one was connected to two computers. And a mesh topology, every computer is directly connected to every other computer. So something you may need to know for this test are the frequencies for wireless. There are 4 standards of wireless, and they're the 802.11, A, B, G, and N. A uses 5 gigahertz, B and G use 2.4, and N uses both. And there are tons of different network types. For wired, they only listed a few here. Luckily, this test won't get into them in detail, but there are tons of different standards that you could look at here. Other types, cellular is becoming popular. You can do Ethernet over 4G. Voice over IP is a popular service where you're using your phone over the internet. And it is becoming a much cheaper alternative to the telephone system. Infrared is not in use that much anymore, but for short range it used to be used to connect laptops to laptops. Previous to Bluetooth, infrared was a quick, easy way to transfer files between computers. So the cable that you use in most of these installations is called UTP, or unshielded twisted pair, and there's a picture of it in a minute. Common ones are Cat5, 5E, or 6. It uses those RJ45 connectors I talked about. Shielded twisted pair is the more expensive version of UTP, and STP has a metal braid around it that protects it from noise. And here they're showing unshielded and shielded twisted pair. You see we've got shielding over here, and in the blue wire we've got it's unshielded. So fiber optic is another option, and fiber optic is by far the fastest connection, but it's also the most expensive. And there are different types of connectors on fiber. An SC is a square tip subscriber connector, an ST is a round tip, and an FC is a round connector for a fiber connector. I personally did not get questions about fiber connections on this test. I did on the Net Plus, but not on the A Plus. One thing I would say make sure you do know from this, though, is the difference in single and multimode. Multimode fiber uses multiple frequencies and at shorter distances. Single mode can go very, very long distances, and it uses a single frequency. But it requires a more finely tuned laser for single mode fiber, so it's more expensive. Coaxial, used in the bus technology now used by your cable TV. There are different types of coax, and they're all called RG, a registered gauge. Here they gave examples 59 and 5. And the connections on these types of coax cables, if they're used for computer, it's going to be what's called a British Naval connector, or a BNC connector. If it's the one that goes on your TV, that's called an F-type connector. And on these numbers, if it has a U behind it, it means it's a cable that you can bury under the ground. So an RG59U, for example, is a 59 cable that can be buried under the ground. And they may require a transceiver to connect to a switch or a host. Okay, so PVC wire is very durable, but it's poisonous when it's burned. And in drop ceilings in a lot of places across the country, the return air system is actually just part of the air up inside the drop ceiling. And because of that, fire code says that you cannot use PVC wire in a drop ceiling if the return air is part of the area, if the plenum is up there. And plenum means that area where the return air comes. Plenum cable produces less toxic smoke, so it is usually required in suspended ceilings. So troubleshooting network, check the cables for damage, check the insulation, check the cables first of all. That's normally the problem when you have problems with a network. There are lights on the back of a card called a link light, and if that light is green and solid, it usually means there's a connection that, maybe it isn't a cable issue. Verify the correct impedance on the cable if it's a coaxial cable. I've seen all kinds of errors where a cable run was too long, or I've heard instances of a rat eating through a cable and causing, a connection not to work. So check your cable first of all. And that is 16 part A. Are there any questions? All right, in part B, we're going to talk about network interface cards, switches, hubs, repeaters, and routers. We'll talk about IPv4. I may mention IP6, so y'all be aware of it. We'll talk about file and print sharing in Windows, and how to utilize fully qualified domain names and UNC names and what those are. And then briefly, we'll go over command line tools, because that's something I think you may see on this test. And then troubleshooting. All right, so putting a network card in a computer, basically, unless it's a server, you're probably not going to do this much anymore. Most motherboards now have got network cards built into them. Maybe you're going to use a USB, though, and it needs drivers to function as a network adapter. Most are plug and play, though. You plug them in and they'll ask for the driver if they need it. You may need to know the IRQ and IO address range, but that's really not anymore because that's all auto. The media type, that's only on old cards that you would have to do that. And then full and half duplex. And you should always run full duplex if you can. Half duplex means that it can't transmit and receive at the same time, so it's going to be slower. With the wireless, you've got some other things you've got to set. You've got to set the SSID, the channel, or the key if it's WP, WPA, or WPA2. And usually you set the SSID, the channel will be auto-selected. So a hub and a switch are something that you need to be aware of, and you don't really have to know a lot of the difference of them for this. But a hub is older for a star network, and all devices share the bandwidth. There's no security. A switch memorizes the MAC addresses, which is the physical addresses of the cards of all the computers on the network, and only sends data to the port that it needs to go to. Both switches and hubs can be connected together with a crossover cable. And a crossover cable is basically where you wire one side of your RJ45 cable one way and the other side the other way, and then you plug it in and you've reversed the transmit and receive wires. Here is a simple switch network, and they say this is also known as a broadcast domain. All hosts on this network can reach all other hosts without the need for a gateway. Okay, so a repeater is a device that enables you to run a cable pardon me, y'all, longer than the official cable limits of Ethernet. A hub and a switch can also be used as a repeater. A bridge switch connects two segments of the same network using the same protocol to each other. And a router can then connect multiple networks together to create different networks. Routers are what allow the internet to be what it is. It's really just a huge collection of networks that are all networked together. So, installing protocols. NetBEUI is an old one. Basically, ignore it. It's not used by anything anymore. TCP/IP is everything. And there are two versions, IP4 and IP6. If it's Windows Vista or newer, IP6 and 4 are both installed by default. In XP, only IP4 is installed, and you can add 6 if you've added Service Pack 2 or higher. To install any of these, you would go to the Control Panel, Network, and Sharing Center, and manage the network connections. Right-click the connection, select Properties, and click Install to select the protocol, then click OK. So, with IP4, you're going to have an IP address, a subnet mask, a DNS server, a gateway, and WINS configuration maybe. And you're going to get this information from the network administrator. Here is the screen, what the screen looks like in XP where you put that information in. And you'll notice that in the first one here we've got it set as obtain IP address automatically. That uses what's called DHCP, or Dynamic Host Configuration Protocol. And in almost all modern networks, that's what's going to be used. If you're using a static address, which means you've assigned it an address, there's probably a specific reason you're doing that. And that's not as common anymore. Even at home users, usually the router is going to assign this for you, so you don't have to go in and set this. So here they're just talking about DHCP. It provides the addresses from a preset pool. To turn it on, just go and set Obtain IP Address automatically. Under Advanced, you can add more than 2 DNS servers. This is where you add WINS. You can also add multiple gateways here if your network requires it. So network addresses have two parts, the network part and the host part. And the way they describe it, the network part is the left side and the host part is the right side. And it's determined by the subnet mask. And the length of the subnet mask determines the network number. So what that leads us to are these classes of IP addresses. And now, if this were Network Plus, I would say you're definitely going to have these. You may or may not see this on the A+, but it's something that, you know, if you haven't taken the Net Plus, but you're going to, you need to learn this. A Class A address has a starting address from 1 to 126. They show 127, and technically 127 is an A, but I'm going to talk about that in a minute, why you don't use 127. B is 128 to 191. A C is 192 to 223. And D you don't have to worry about because it's special. But Class A, B, and C addresses are what are in use on the internet. The reason 127 is special is because that is what's called the home address. And your computer should always answer to 127.0.0.1. That is the loopback adapter on your computer if it's running TCP/IP. If you don't get a response when you type that command ping 127.0.0.1 on your computer, then there's probably something wrong with TCP/IP on your computer. In the IP6 world, that same address is ::1. So if you ping ::1, you should always get a response if IP6 is working on your computer. All right, in each of the sets of addresses, there are private addresses that are reserved. And those are addresses that are not used on the internet, but they are used for computers that have one public internet address and then more computers locally that use those. This is where what a process called NAT translation comes into play. And NAT, or network address translation, basically was a way to try to save internet IP addresses. And it allows one public IP address to handle more than one computer internally. If you look at our lab at Barksdale, for example, I've got 11 computers in there, but I only have one public IP address. So in there, I've assigned 192.168.254. whatever as IP addresses. So each machine has to have its own IP address, but they use NAT so that they only have to have the one address to get out on the internet. Here they mention the loopback I talked about, 127.0.0.1. The APIPA address range, and we'll talk about that in a minute, that's one you need to memorize. 169.254.0.0 to 169.254.255.255. And then finally, multicasting is any of the 224 addresses, and that's used for network and routing stuff. So APIPA stands for Automatic Private IP Addressing. And the reason this came about is that in the old days, Microsoft's NetBEUI, or NetBIOS, could communicate without a server needing to assign it an address. But since everything moved to TCP/IP, what happens is if a computer doesn't reach a DHCP server, it would just fail out, and the computer wouldn't be able to talk to anybody else on the network. Well, APIPA comes into play, and if you have just a few machines and they don't get to a DHCP server, they will randomly pick an IP address in that 169.254 address. First, they try to ping it to make sure it's not used anywhere else. And if it's not, they assign themselves that address. And by those two addresses being on the same network, the computer can communicate with other computers on that network, even if the DHCP server's down or didn't exist. So this is what allows you, even though we use TCP/IP now, to just plug in two computers and they can talk to each other, even if they're not on the internet. So file and print sharing, this one's pretty self-explanatory. To install it, go to right-click on Properties under Network Connections, add File and Print Sharing. It's installed by default on Vista and everything new. And click on the folder options and advanced sharing and clear the simple sharing. That will allow you then to assign permissions as to who you're going to allow to access what files. Here they're showing a graphic of that. In Vista, Control Panel, Network and Sharing Center, down arrow next to File Sharing to turn it on. Click Start then on the computer. Navigate to the folder you want to share, right-click on it and click Share. Everyone will allow it to be shared to anybody. Guest will share it to other computers and everyone. And once you're done, hit share and hit done. Here they're just showing a shared folder. This is using the basic settings. Click the button to share it, name it, and then if you click allow users to change files, that gives them read-write permissions to it. Otherwise, they can just read it. Have all of you shared a file on Windows before? Okay, good. All right. You may need to set up a network client, and that's done under Network Places and Properties. You need to know the name of the server with the resources, and if it's a print driver, you need to know the location of the drivers. You may need to add a printer URL or Uniform Resource Locator. And one thing that Windows uses is what's called UNC, or Universal Naming Convention. And basically, that's in all the versions of Windows now. You can go to a run prompt and type / the name of the server / the name of the share. And that will bring up what is shared on the server. For example, I've got a computer that I run as a server here at home. I call it Atlas, and I've got a directory on it that I've got all of my Wii games backed up into. So that's a directory on a server, and see if I click on it, the uniform resource or UNC name is //atlas/software/backup of Wii games. You can also connect to them by IP address. I could have easily just put in / 192.168.54.3 in my case here at home for that server, and it would have let me get to it as well. Alright, so what you do in some cases is map a network drive. And what that means is you're assigning a resource on a network a drive letter on your local computer. And that is for programs that don't use UNC names, or if you want to be able to just write little batch files to copy things back and forth, you can just map a drive so that you can get to a resource on another computer automatically. And if you click the Reconnect It log on, it will reconnect it every time you reboot your machine. Here to do that, it's very simple. Right click on your network, go to Map Network Drive, pick the letter and put the name, and then click or don't click Reconnect It log on based on what your preferences are. Okay, so if you are installing a new browser, which is one of the first things I do on a computer because I hate Internet Explorer. If the company is using a proxy server, you'll need to know the proxy information to put into the browser. In IE, that's under Internet Options and LAN Connections. In Firefox, it's under Option, and I think it's called Network Connections. And in Chrome, it's under Advanced Settings and Under the Hood. If they are on a dial-up network, you might set it to automatically dial up. I hope they're not on a dial-up network, but if they are, you can set it to dial it up for them. If they have an extremely slow connection like dial-up, you can set it where they don't see graphics. And then something you may need to set are specific security settings for Java. Here they're showing an example of where you go to set a proxy. Alright, so there are some commands you can use from a command line to determine if a network is properly connected. One command that is commonly used is net. And if you type net without anything, it'll just show the different commands. If a drive is mapped NetUse will show what is mapped from the command line. You can also stop and start services with net. NetTime, if there's a time server on the network, will give you the time that it shows. And see, I'm not running a time server on my network here. Ping is another common command. And what ping does for you, ping goes out and sees if it can get to a connection on the internet. So if I ping www.google.com, for example, getting a response there is telling me that google.com is up. One that I remember, I always ping 8.8.8.8. That's Google's DNS server. And the reason I picked that address, it's very easy to remember, and Google should be up, almost all of the time. Trace RT is another one, and this shows the paths that a connection has to go through to get from your computer to, if I could type, shows all the paths that a connection has to go to get from your computer to the other computer on the other end. So see here, traceroute 8.8.8.8 shows me several connections have to be reached. Before we get to google.com. These stars normally mean that a device is not responding, and that doesn't necessarily mean that it's bad. That device timed out there, device 14, that's probably a firewall. So Google's probably got a big firewall in place, before you get to their DNS server. So you see it took 15 hops. There are 15 devices between my computer and Google's DNS server. NSLookup is another one. I cannot type today. And NSLookup lets you find an IP address based off of what a device is, a name is, or find a name based off an IP address. So if I put in www.bipsy.edu, for example, it tells me that BIPSY is 76.165.211.151. And then a final command to know is ipconfig. And this is going to give a lot of information on my machine, but what this does, this shows you what your IP addresses are of the devices in your computer, of your different network cards. Mine's got several network cards because I have several virtual machines installed on here. But you see there, my actual IP address is 192.168.54.56. Or my IP6 address is above it, FE80, 41C3, and so forth. I'm not going to read it all to you. But that'll give you some information. If you do ipconfig/all, in addition, it'll tell you the MAC addresses, the physical addresses. So see here, my computer, it's got a Realtek card in it, and the MAC address is 406186.0B, and so forth. Here they're going to show screens of all of these. Here they're doing an IP config. So trouble that does happen on a network, if IP addresses are manually assigned, you might have a duplicate IP address. If the network is slow, check for bad cables. If there's a hub, take that hub out and put a switch in its place. If it's wireless, maybe change the channel on the wireless. Maybe your neighbors are using the same one. Problem connecting to printers, check the UNC path. For browsers, check the internet options, the security settings, and the proxy server settings. So also check the default gateway. Make sure good default gateway is set. And that is a quick rundown on networking. Are there any questions? All right. Let me go ahead and I'll stop the recording here. Remember for next time, watch 17 and 18. I'm fixing to put them on Blackboard now. And don't forget to go ahead and do as many of your chapter quizzes as you can. All of that's going to be due Friday. And then on Thursday, we will let everybody present their final projects. I'll look at the computers y'all have built. And I'm going to open the floor to any questions. So think back over everything we've done in this course, and if y'all have any specific questions or anything I can answer before y'all take the exam, let me know and we'll go from there. I will see you all on Thursday.